Welcome, guys. We have another question here, which is example 4. So, here in this case, we are asked to evaluate the line integral given this expression. Take note, the path is closed. If it is closed, you have the sign. If it's not closed, then that means you will not see this in it. Um, just like the first example that we did, it's just a curve of y equals 4 square. So, what did you notice about the question? It does not have this closed sign. Okay, so it does not have that closed sign. But wherever you see this, that means all the parts are being closed. So here in this case, we already have the int. They said it forms the part C comprises the three sides of a triangle, and that means it is closed. For you to have a triangle, that means all the lines are closed. Here in this case, um, we don't have any equation, right? So you have to be the one to find the equation of those lines. So first thing you have to do is to locate each of these points. So then we have the y coordinate, sorry, the y-axis and the x-axis. We have the y-axis and then we have the x-axis in this form, such that we have center O. This is O. O is 0, comma 0. And then um, point A is at 1, comma 0. That means x is 1. X is 1 and y is 0. So let's say this is 1. So this is B. Sorry, this is A rather. A is 1, comma 0. When x is 1, y is 0. Do you agree with that? And at the same time, point B is when x is 0, y is 1. When x is 0, y is 1. So it will be around there. Okay? So this is B. When x is 0, y is 1. So remember that I said if it is closed, this thing is counterclockwise towards the negative part. So it goes from this starting point here, start joining this line. So that means you can't go like this. You go counterclockwise. So it goes like this direction, right? So when you get to this point, you move towards this direction, counterclockwise. So I have this. So if you go towards this direction, then you move like this. Then finally, when you get to this point, you move towards this point. So how many parts do I have to complete the journey? I have OA, I have AB, and I have BO. So that means my final answer is the addition of those evaluations. That I have to evaluate the line integral along this line, along OA of this expression I have here, x squared dx minus 2xy dy. So I think that's all for that one. What's the next one? Plus, you add it with the next one. This for part OA. Then I also have for part AB. You have to do the same thing for part AB. So then you are using the same expression given to you in the question. Okay. And finally, what's the final part? That's BO, along the part BO. And that's x squared dx minus 2xy dy. So this is what I have. Now here in this case, I need y. We used to substitute value for y. So how will you get y, the equation of this line? How will you get y itself? Y implies the equation of this line from here to here. So if you have line OA, if you have this line from, this is the line here, from point 0, comma 0 along this point A, and A is what? A is 1, comma 0. So what's the equation of this line? So you can just use the equation of a line is y minus y1